Welcome to Spring LIB.
Our question says the magnitude J of the current density in a certain lab wire with a circular cross-section has a radius of R equals to 2.00 millimeters, or 2.00 times 10 to the minus 3 meters. It also says J is given by it equaling to 3.00 times 10 to the 8 times R squared. So J is equal to KR squared. So our constant K here is 3.00 times 10 to the 8 with J in amperes per square meter. What is the current through the outer section boundary bounded by R is equal to 0.900 R and R is equal to R? So our boundaries here are lower. We'll call this R1 is equal to 0.900 R. This is big R. And R2 is just equal to big R. Okay, so to find the current through the outer section, we're going to need to integrate the expression J over the change in area, dA, from R1 to R2. So this is equal to KR squared. This is the integral here from R1 to R2 of KR squared, and then dA, this is squared here. dA is 2 pi R, because that's the area, times the change in R, dr. Okay, so we can combine the r's and pull the constants out front. So we have k times pi integral of r1 to r2 of r cubed dr. Well, the integral of r cubed is r to the fourth over 4. So this is equal to 1/2, because the 4 comes out front, and then the 1 over 4 comes out front and multiplied by 2, so that becomes a 1/2 times pi times k times the top, which is r squared, or r2 to the fourth minus r1 to the fourth. Well, r2 is r to the fourth minus r1, which is 0.656, since that's what 0.9 to the fourth equals, 0.656 times r4. So you plug the values we were given for r4 and for k into this expression. This comes out to equal 2.59 times 10 to the minus 3. And current, so it's units of amperes. You can box that in as our solution to the question.